Welcome to the notes on functions and domain and range. All right, after this lesson, you guys should be able to determine whether a relation is a function and find the domain and range of a relation. So there's that first word, and we got relation. What is a relation? Well, right here, it's a set of ordered pairs. All right, many ordered pairs, we just call that a relation. And then we're going to find out what domain and range is. Okay, domain, all right, that's the x values or the x coordinates in your ordered pairs. All right, so when you think domain, you want to think x coordinates or the x values. All right, and then when we talk about range, all right, that's going to be the y coordinates in your relation. All right, which is again is a set of ordered pairs. So you look at all the ordered pairs, all the y values are the range, all the x values are the domain. Now, what is a function? All right, whether a relation is a function, big thing right here. All right, a function. Here's a definition. All right, it is a set of ordered pairs that assigns to each x value exactly one y value. So what does that mean in layman's, in regular terms? All right, x value or x coordinate can't repeat. All right, so there can only be one x coordinate. All right, the same x coordinate can't repeat. And let's take a look at a couple examples. The first one we see, determine whether each relation is also a function. So we just look at the x values, all right? Because the x cannot repeat. -1, 2, 7, 8. Okay, x does not repeat, so every x coordinate has exactly one y value. So yes, this is a function. Let's look at the second one. Now don't be confused, all right? If you notice that 3 repeats, but that's the y value. Again, function has to do with the x coordinate not repeating. Okay, so the next one, all right, let's look at 0, 1, 0, 7. Oh, we see that 0 repeats. All right, so that's an x coordinate having two different values. It has -2 and 3. So that is not a function. So that's how we determine whether a relation is a function. Now, a couple more examples just so you get the idea. Now, they might put it in chart form where you got to plot points. Okay, so what is this point right here? Well, here's our origin. Kind of hard to read, but if we count to the bottom left, that's back 1, 2, 3, 4, 5, 6, 7, 8. Back 8 down 1, 2, 3, 4, 5, 6. So that's -8, -6. We look over here, that's back 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7. So that's -4, 7. All right, right here it's 0, 8. You don't move left or right, but you go up 8. So that's 0, 8. And then over here we go over 1, 2, 3, up 1, 2, 3, 4, 5. So that's 3, 5. And then we come over here again, it's 3, but now we're down 1, 2, 3, 4, 5, 6, 7. Okay, so that's 3, -7. So let's determine whether it's a function. Well, the domain, that's all the x values, and you're literally just going to list them out. So we write it like this. Okay, domain. Let's start left to right. -8, -4. All right, 0. And then 3, we don't have to repeat it. It appears twice, but we only have to write it once. Okay, then the range, well, that's the y values. Again, this is x, this is our y. So then we just look at the range. I'll go bottom up. So we got -7, -6. We've got 5, we got 7, and we've got 8. Okay, is this a function? Well, we already talked about the letter 3, or number, 3 for x repeats. So this is not a function. So that's how these problems work. You're going to list out the domain, list out the range, then determine if it's a function. Sometimes they don't give you the pictures. They just list them out for you. The domain, well, here we go. Domain, again, is x values. So let's look. We've got, and I'm just going to go work left through -6. We've got -3. We've got 0. We've got 3. And we've got 4. Well, right now I know it's a function because none of the x repeats. Now let's look at our range. That's our y values. Again, y, so it's going to be 8, 2, 7, 9. And there's 2 again, but we don't need to rewrite it. So we just leave it just like that. And again, even though that y repeats, x does not repeat. So yes, it is a function. Take a couple more quick examples, then we'll be done. All right, a vertical line test. This is a really easy way to determine if a graph is a function. Okay, if you can draw a vertical line through a graph and it intersects more than once, the graph is not a function because that means you're hitting x in the same spot twice. And I'll show you that in a second. So determine whether a function, here's a picture. Can I draw a vertical line through this at anywhere and it intersects the graph more than once? Nope, it's only intersecting every time one time. So yes, this is a function. Again, draw some vertical lines. Nope, never intersects more than once. So yes, this is a function. Let's try this one. Okay. Oh, yep, you can see this intersects more than once and multiple times, but if I can see right here that these intersect the spot in two spots, so I know that that has the same x value. So that is no, not a function. I think I put a couple more here down at the bottom that look goofy. Even though they look goofy, again, it still doesn't intersect in more than one spot. So yes, this is a function. And you can see, again, cannot intersect it in more than one spot. So yes, this is also a function. So that's the vertical line test to determine whether a graph is a function. And now we know how to determine if relations are functions.